Hello everyone. In this video, we are going to take a look at how we can do cross-programming invocations in Solana. So what I mean by cross-programming invocation or CPI is that a smart contract will call another smart contract, or in Solana's case, they are going to be referred as programs. So in our program, we are going to call token program to transfer our funds to another account. For this, we can implement our own token and implement our own transfer function. But what I'm going to show you is in this video, we are going to call the transfer function inside the token program. So we will be having an easier time transferring our funds. So without further ado, let's start with this template. So I'm going to be working on the template and I will give you the link to access this, and you are highly encouraged to work on this template since it contains all the necessary imports and necessary cargo toml versioning of the libraries. As you can see, it's empty with just the imports. So I'm going to delete this OK statement. In this program, actually, we are not going to have separate instructions. So it's going to be a very tiny example, and we are just going to transfer the funds. For that, we are going to use the accounts, which is given to us without the instruction data, as I mentioned, with the underscore. I'm going to iterate through the accounts that we have. So for this, I will use like this. And I'm just going to get a mutable reference to it. So in order to work, this program needs a couple of count infos, and I'm just going to iterate through them. And this is going to make sure if they are not provided by the user, this program is not going to work. So first of all, we need a source info, which is going to represent whose money we are transferring to. And for that, account info, which is iterable, I'm going to try to access it. And just like source info, I will have a destination info as well, which is going to represent whose account I'm transferring to. Let's keep the order. So the second thing is mint2, which is going to contain some information about the token that we are transferring. And the fourth thing we are going to get is authority info. And this is going to contain information about do we have the authority to transfer these tokens or not. And lastly, we are going to need the token program. So which token are we transferring? So mint2 was specific information about the token, but since we are going to call another program and use transfer function implemented in that program, we actually need information about that program as well. So for that, I will use the same syntax. So our program needs to get these information with this order so that it's going to work. Let's move on to the expected authority to see if we have the correct seeds and correct authority. And for that, I will have an expected authority with bump seeds. And this is going to be something we are going to find on our own with find program address. And for this example, we are going to use string called bAuthority. We are going to be looking for this string, and we are going to give the program ID, just like what is suggested to us. If the expected authority we get from here is not equal to the authority info we get in this line 29, we are going to give error saying that these seeds are invalid and you don't have access to actually be doing. So program error, and inside we have an invalid seed just for this. So this was wrong. Next, account info. So actually we have made an error in here. It would be like this. And it's saying that we don't have an else case, but we are just going to implement it. So it's fine. We can move on to source accounts. So let's create a source account actually, which is going to contain account information from the source we have get. Source info is not an actual account, so we need to convert it to account so that we can work on it with Rust. We are going to call accounts unpack function, and inside we are going to try to fit this source info with a borrowed reference. And in case this fails, we need question marks. And from here, we need to get the account. So one of the functionality of our program is that it's going to transfer all the tokens that this user has. For that, from this account, we have the mint, owner, and amount. And this amount contains the balance of this account. So we are going to transfer all of the funds that this account contains. Similarly, we are going to try an account from mint. So mint unpack. And in here, we are going to give mint info, not mint info. Actually, we can call this info. It's mint too. And we are going to, again, try to borrow the data. And in case we have this data, we are going to get the decimals from this mint function. Right now, we have the account info as our source. So we know which account is sending the money and which amount we are sending it, which decimals. So we are actually ready to actually use the transfer. So I will say here, invoke transfer from SPL token. So we are going to be using instruction of SPL token. For sending another program invocation, we are going to use this invoke sign. Also, it's going to get instruction, account info, and signer, really similar to what we have in our entry points. So let's start with actually the instruction. Our instruction is called transfer check, and it's going to check for lots of things that we don't need to worry about on our own. So the first of all, we need the token program ID. We have this in token program info. That key, and after that it's going to check for a source public key, and we also have this in our source info. So let's call source info.key, and for the mint public key we also have this from our account. It's called mint info.key. Similarly, for the destination we have the key. For authority also, and this signer public key is actually this account, so I'm going to leave it null. And in case it was a multi-sig account, I could have just given another program's public key, but I'm not going to be doing that. And we have the account and decimals with these names, so it's fine. And we need to unwrap the results from this transfer check. Actually, we have given this a wrong name. This is amount. All right, so we can continue right now. For the account infos, I'm going to give a reference to an array. So the first of all, we need this source info with a clone. Similarly, we need mint info with clone. We need destination also. So I'm just going to give every account that it requires, that we got actually from our own account inputs. And token program info.cloud. For the authority, this signer seeds, I'm going to give a reference to our B authority string. And since this is going to be used to derive our bump seed, so let's actually call cargo format so that we can see it better. So our program is right now ready. And in the next video, we are going to see how we can test it to see if it actually transfers some tokens or not.